Let's look at some basic properties of integration. The integral of k times f of x dx is the same as saying k times the integral of f of x dx. This should strike you as very familiar to differentiation rule, where if you have the derivative of a constant times a function, you can actually pull out the constant and differentiate the function on its own. The same thing works for integration. And again, similar to differentiation, if you have the sum of two different functions, you can integrate the functions separately on their own. So I can write this as integral of f of x dx plus the integral of g of x dx. The same holds for subtraction, of course. As we know, subtraction is simply adding the negative, so I could have written this as plus or minus g of x without affecting the rule. We can generalize the two rules above by writing that the integral of the sum of functions is equal to the sum of the integral of the individual functions. Now, if this looks a bit advanced, then don't worry about it. I'm simply generalizing the rules that I wrote above to any number of functions, not just two functions. You will usually be expected to know the derivatives of most basic functions. Polynomials, trigonometric, exponential, the list goes on. And the same goes for integrals. You'll be expected to know most of the integrals. But sometimes it's just good to have a handy reference of all the integrals. And for this, we use a table of integrals, which contains all the basic integrals plus more. Now, I highly recommend that you make your own integrals table and store it in a handy place. Just search for integration table online and copy down the reasonable looking results. Writing it down by hand has the added benefit of helping you to memorize some of the integrals. I have just posted one example here, but you can add many more integrals to your own table. Let's now use all the rules of integration that we learned to integrate these functions. Take a look at the first example. We know that the integral of a sum or difference of functions is the same as the sum or difference of the integral of the functions. So we can rewrite this as 4 times the integral of x squared dx plus 3 times the integral of sine x dx minus 3 times the integral of 1 over x dx. And this, we know, becomes 4 times x cubed over 3 plus the integral of sine x is negative cosine x, so we have 3 times negative cosine x minus 3 times ln x plus c. Simplifying this, we can write this as 4x cubed over 3 minus 3 times cosine x minus 3 times ln absolute value of x plus c. Now for the next example, we're going to divide every term in the numerator by root x. So this gives us the integral of 5 minus 3x squared over root x plus 1 over root x dx. Rewriting this so that it's easier for us to integrate, this gives us integral of 5 minus 3 times x to the power of 3 over 2 plus x to the power of minus 1 over 2 dx. Now I'm not going to write the integrals separately, but I'll directly use the power rule for each of them. And this gives us 5x minus 6 over 5 x to the power of 5 over 2 plus 2 x to the power of 1 over 2 plus c. As usual, you can pause the video and try these on your own. The solutions will be revealed in a few seconds.